Okay, so today starts 3-1 polynomials. So a monomial is a number or a product of numbers and variables with whole number exponents. A polynomial is a monomial or a sum or difference of monomials, sum or difference being adding or subtracting. Each monomial is in a polynomial is a term. Because a monomial only has one term, it is the simplest type of polynomial. The polynomials have no variables in denominators or exponents. They also have no roots or absolute values of variables, and all variables have to have whole number exponents. I guess I should have spaced these out better. But these are all examples of polynomials. 3x to the fourth is a polynomial, and that would be a monomial because there's only one term. 2z to the 12th plus 9z to the third is a polynomial. And 1/2 a to the 7th is also a polynomial. See, there's no variables in my denominators, and I don't have a variable as an exponent. There's no letters that's in the denominator or the exponents. Some examples of things that aren't polynomials would be ones like 3 to the x, absolute value of something makes it not a polynomial, 8 over 5y squared because the variable's in the denominator, or 1/2 square root of x because I'm taking the square root of x. So that automatically makes it not a polynomial. The degree of a monomial is the sum of the exponents of the variables. And we'll try to identify the degree of each monomial below. So when we're looking at the degree of a monomial, if I look at this one, z to the 6th, it's just the sum of the exponents of the variables. So this one only has one variable, z, and the exponent is 6, so the degree of this monomial would just be 6. If I look at b, there is no variable. So since there's no variable, the degree of this one would be 0. If I look at c, here I have 8x y to the third. The degree of the monomial is adding the exponents. This is just x, which means it's x to the first. So the degree of this monomial would be 1 plus 3, which would be 4. And then for part D, I have a squared b, so that's just b to the first, and c to the third. I add the exponents together, 2 plus 1 plus 3. My degree of this one would be 6. Okay, now I want you to take a few minutes here and try to identify the degree of each one of these. So the first one would be 3, because that's our exponent. The second one would be 0, because there is no variable. For C, it would be 5 because we add the 3 and 2. And then for D, it would be 9 because we have to do 6 plus 1 plus 2. A degree of a polynomial is given by the term with the greatest degree. So if we have multiple terms, we're looking for the one with the greatest degree. Polynomial with one variable is in standard form when its terms are written in descending order by degree. So in standard form, the degree of the first term indicates the degree of the polynomial. And the leading coefficient is just the coefficient of the first term. So we're going to put it in order from degree, from highest to lowest. And the degree of our polynomial is the highest number, the highest degree. And our leading coefficient is the number that's in front of it. So if I put this in standard form already, I started with the highest degree, which is to the third power, then plus 8x squared plus 3x minus 17. So the degree of each term, the first one is 3, the second one is 2, the third term is 1, and the last one is 0. So it is in order because the highest came first. The degree of our entire polynomial is the highest number. And our leading coefficient is the number that's in front of the highest term. So 5 would be our leading coefficient, and 3 would be the degree of the polynomial. We can classify a polynomial by its number of terms. A polynomial with 2 terms is called a binomial. 3 terms is called a trinomial. And we can also classify the polynomial by its degree. So if we're classifying them by degree, if it has a degree of 0, or if it's just a number like -9, then that would be a constant. If it has a degree of 1, like x minus 4, that would be called a linear function. If it has a degree of 2, like x squared plus 3x minus 1, that's quadratic. X to the third gives us a cubic. If the degree is a fourth power, it's a quartic. And if the degree is to the fifth power, that is a quintic function. So now we have to rewrite this in standard form and identify the leading coefficient, degree, and number of terms. And then we're going to name the polynomial. So for A, if I have to write it in standard form, it means that I have to put the highest exponent first. Sometimes it might help you to divide these out or like break them up into terms like this. Remember that anywhere there's a plus or a minus, it separates the terms. So here I had 3 minus 5x squared plus 4x. So I'm going to go with the highest degree first. So that's negative 5x squared, then plus 4x plus 3. If I look at my exponents, I should see that it's 2, 1, and 0. There's no x here, which tells us it has an exponent of 0. So then the leading coefficient, or LC, is the number in front of my highest degree. So that would be negative 5. The degree is 2. The number of terms, I have 1, 2, 3 terms. And now I can use my degree and number of terms to name this. It has a degree of 2, which means that it is a quadratic. Almost spelled quadratic wrong. a quadratic. And then 3 terms means it's a trinomial. And so that's the name of my function. I can look at this name alone, and from it I can tell that I'm looking at a polynomial with a degree of 2, because it's quadratic, and 3 terms in it. For the second one, I can rearrange this one as well. 3x squared minus 4 plus 8x to the fourth tells me this is going to be 8x to the fourth, so that's my highest exponent, plus 3x squared minus 4. My leading coefficient is 8, because that's the number in front. The degree is 4, it's my highest exponent. And it also has 3 terms. So how would I write this? I would start with my degree, which is 4. Go back to the table. In the table it says if the degree is 4, it's quartic. So that means this is a quartic. And then how many terms? It was 3. So a trinomial.